G'day guys, we've got quite a quick and easy differentiation problem today where we've been asked to determine the gradient of this particular quadratic at the points where it crosses the x-axis. Now what I've done is I've drawn the actual function on a set of Cartesian coordinates to make it easier for you to understand what I'm doing. So basically what we have to do is we have to find the gradient at this particular point and this particular point here. So first things first, we have to figure out exactly what those points are. In the exam, you wouldn't be given this nice graph here. You'd have to work this out yourself. So the best way to do this, for me anyway, is I like to factorize the quadratics. So for instance, I'm going to factorize this particular quadratic to y equals x take 8, x plus 3. Now at the x-intercepts here, this particular function is going to equal 0. Now we've got this little rule called the Null Factor Law. I like to just abbreviate it, NFL, which basically means if you've got two numbers multiplied together to equal 0, at least one of them has to be equal to 0. So from here what I can say is that either x take 8 has to equal 0, so x would have to equal 8, or x plus 3 has to equal 0, so x would have to equal minus 3. So those are our two x-intercepts, these 2 points here. So now what we have to do to determine the gradient at these 2 points, we have to find a gradient function or differentiate our quadratic. Now I'm going to go back to the original formula here and differentiate this particular one here. So I've got dy dx. And this is going to be simply equal to 2x take 5. Now what I've got to do is I've got to evaluate this particular derivative at the point x equals 8 and the point x equals negative 3. So for the first one, I'm going to say, well, dy dx evaluated when x is equal to 8 is going to be equal to 2 times 8 minus 5. 2 8's 16, take 5 is 11. So there's our first solution. I'm then going to evaluate this gradient function here at x equals negative 3, and this is going to be equal to 2 times negative 3 minus 5, which is equal to 2 times negative 3 is negative 6, take another 5 is negative 11. So the gradient of the function y equals x squared take 5x take 24 at the points where it crosses the x-axis are m is going to be equal to negative 11, as well as m is going to be equal to a regular 11. And that is our solution there, guys. So just remember, in an exam, you're not going to be able to use a graph like this. This was in a section of the exam where you couldn't use a calculator either. So understanding that you can use factorization to find the x-intercepts, you could also use a quadratic formula. I just find this a little bit quicker if you know how to factorize. Once you've done that, you just have to differentiate to find the gradient function, substitute in your x points, and you are cooking with gas. The trick is with questions like this is not to make any silly mistakes as you try and race through it to tackle more complicated ones. So guys, I hope the video helped. If it did, give it a thumbs up. Subscribe to my channel. I put out new videos all the time. But until next time, guys, you just keep on chugging on, keep on doing what you're doing, but most of all, make sure you keep on enjoying your maths. I'll see you next time.